In the following tutorial, we will be examining the behavior of a bicycle frame when a 180-pound person is using the bike. Through this tutorial, we will gain further understanding about not only the behavior of solid mechanics, but also finite element analysis. The program that was used for this tutorial is ANSYS AIM. Within AIM, materials are defined using Poisson's ratio and Young's modulus. Within this problem, we will be simulating an aluminum bike frame. Aluminum has a Poisson's ratio of 0.33 and a Young's modulus of 7.1 times 10 to the power of 10 pascals. Concerning the boundary conditions, a bicycle frame rests on two wheels, and therefore we have the connections on the frame defined as supports. We also define two forces acting on the frame, the first being 130 pounds acting downwards on the frame where the person would be sitting on the seat. The second force is 50 pounds acting in line with the bicycle frame, originating from the point where the handlebars would be connecting. In this way, we have attempted to simulate a person riding the bicycle and not simply sitting on it.
To start your project, you want to press on Structural and choose to import existing geometry. From the pop-up window, select your geometry and press Create. Your workflow is shown down here, and in the top left-hand corner is where you can open and save files. If you click on Geometry and you press on Edit Geometry, you can make any geometry changes you need to here. When you're done, just hit the X in the top right corner. Go into your Meshing tab. All of the preset values should be fine here. You can define the overall mesh size with this slider up here. So you can just update your mesh. Go over to your Physics tab once your meshing is done. Go to Material Assignment, and there should already be a material assigned to the body of the bike, so you just need to change it to aluminum. Then you can return to the main Physics tab. Go to Structural Conditions and Add Support. Go up and choose Face Select. Go to where the handlebar would attach to the bike. Rotate your view so that you can see the bottom of the bar and that it runs vertically, then select the bottom face. Make sure that the support is fixed and then add the assignment. Again, we are going to go into structural conditions, but this time we're adding a force. We are going to add two forces, one for the seat and one for the handlebars. At the top of the vertical bar, where the seat would connect, we are going to select the circular face. We have to change the Define By section from magnitude and direction to directional components. This is because magnitude and direction will create a force in line with the body. We will be adding negative 130 pounds of force in the Y direction only. Go back to the main physics page after you finish that. We are going to add the second force, so again, go to Structural Conditions and add force again. We are going to go to the vertical bar where the handlebars would attach and select the face at the very top. Now you set the force to 50 pounds and choose for reverse direction. This is simulating the force applied from a 180-pound person leaning on the handlebars. Return to the physics page and press Solve Physics. Once physics has finished solving, we can move on to the Results tab. Update your results. You can add or edit results to view different sets of data. By default, you can choose to view equivalent stress or displacement magnitude and view the relevant results for each.
This is a side-by-side comparison of the full bike and half the frame with half the force applied in order to understand whether the simulation holds if we simplified the structure. The data between the two versions are relatively consistent.